Good morning, students. Up to the last lecture, we have studied the point, dew point, and humidity. Now, from today, we have to start new point, that is the specific heat capacity. Okay. So, to study this concept, specific heat capacity, one experiment is given our book. Okay, that condition is given that we have to consider. So, in that condition, they tell that we have to take the boiling water. Okay, so we have to take a boiling water, means its a temperature will be 100 degrees Celsius. Okay, and we have to put three different metal balls in that boiling water. Okay, which iron ball, copper ball, and lead ball. Okay, so these three balls we have to put in this boiling water which having temperature 100 degrees Celsius. Okay, now if you put a three different balls in boiling water, then we know temperature of that boiling water is 100 degrees Celsius. Then we put this ball in that 100 degrees Celsius water. So after some time, what happen? Temperature of that balls will be equal to 100 degrees Celsius. Okay, so because after some time, what the temperature of water and balls will be equal. Okay, so now for next step we have to consider a thick layer of wax. Okay, we know wax, so generally if light is gone, then we generally use candle. Okay, there wax is present. We know if we heat that wax, then it will melt. Okay, it will be melt. So we have to consider thick layer of wax. Now we take boiling water in that these three balls. So now temperature of all three balls are equal. Okay, because we put them in same boiling water. So what we have to do? We have to take that three balls and place on this thick layer of wax. Okay, then we know what happened. We take that balls from boiling water, so as that balls will be hot, and as we place that ball on this thick layer of wax, due to that this layer of wax start to melting. Okay, so we know very basic thing. Now if I ask which ball will be go deeper, most deep as compared to three balls, okay, so we will say that ball will be go deeper and deeper, which absorb more heat. Okay, that ball will be go at lowest point in the wax layer, which ball absorb more heat from water. Okay, but now here we just have to put these three balls on the layer of wax, and just we have to observe what happened here. Okay, so after some time we will say that, okay, this first iron ball go to that much depth and remain stay there. Okay, then this copper ball goes up to that much depth, and this lead ball goes up to that much depth. Okay, so initially if we see the starting condition, okay, we are take out all three balls from the boiling water. Okay, means initially temperature of all balls are equal, same, but if temperature are same, then if we see this scenario in case of wax, so their depth are not equal. Okay, we know if their temperature are same, then their depth should be same, but this case is not happen here. So why this concept is happen? Okay, that is due to the specific heat capacity or specific heat capacity of substance. So we can say that if temperature of all three balls are equal, no doubt about that, but still what about the heat? Okay, we know this wax will be melt due to the heat present in this ball. So we can be made a prediction by the observation of this diagram that initially temperatures of all three balls are same, that no doubt about that, but still whatever the heat absorbed by all three balls are not equal. Okay, so that is the very important prediction we have to make from this diagram, because initially temperature of all three balls are equal, but as we put the balls on the wax layer, at that time we will see that depth of all three balls are not equal. Okay, if that equal, then we may say that their whatever the heat they absorb, that will be equal. But here we see that iron ball go most deep. Here it is in intermediate state, means middle of that two balls, and it is very less deep as compared to iron and copper ball. Okay, so here one prediction we can make, that if their initial temperature of balls are equal, but still heat absorbed by all the balls are not equal. Okay, and the difference of depth is due to the different acquire of heat by balls if their initial temperature are also same. Okay, so here what their absorbed heat is not same, that is why their depth is not same. Okay, so how much heat that ball can be absorbed, that depend on this concept, that is the specific heat capacity. What? Specific heat capacity. And the specific heat capacity of substance is denoted by letter C. What? Denoted by letter C. So here we have to only understand this diagram. Okay, by studying this diagram we can easily understand the concept of specific heat capacity. What happened here? We take three balls, iron, copper and lead. Okay, so their initial temperature are same, because we have to take out that three balls from the boiling water. Okay, so their initial temperatures are same, and then we put that three balls on the thin wax layer. Okay, so we know due to the heat of this ball, wax start to melt and that balls go deep and deep into this wax. Okay, so if we see this iron ball, okay, that will be reach maximum depth, okay, as compared to copper and lead. If we observe copper, then that will be in intermediate state, and this lead, that is less depth as compared to other three balls. Okay, so simply this case is happen due to what? Their heat is not same, acquired heat is not same. Their temperature or initial may be same, but whatever the heat absorbed by that metals are not same. That is why their depth is not same in this case. Okay, so how much heat that ball can be absorbed, that depend on this concept, specific heat capacity. Okay, so specific heat capacity concept tells us how much heat any substance can be absorbed when we have to raise temperature of that substance by 1 degree Celsius. Okay, specific heat capacity means what? The heat absorbed by, we can say, metal to raise temperature by 1 degree Celsius. Okay, that heat is called specific heat capacity of that particular metal. Okay, so what we are talking about metal, one particular condition. Okay, but that may be happen with any substance. Okay, so simply if we have to make definition of specific heat capacity, then we may say that the amount of heat absorbed by substance to raise temperature of that particular substance by 1 degree Celsius, that heat is nothing but the specific heat capacity of that particular substance. What? The amount of heat required to raise temperature of substance by 1 degree Celsius. So actually what happened here, iron, copper and lead have initially same temperature, but if we have to increase what temperature of each three metal by 1 degree Celsius, that heat may be different. Okay, so if we see case of iron, so iron need more heat to raise temperature by 1 degree Celsius. This copper need less heat as compared to iron to raise temperature by 1 degree Celsius, and this lead need copper and iron compare very less heat to raise 1 degree Celsius temperature. Okay, so main basic concept is what, their initial temperature is same, but still their heat acquired at that temperature is not same, because what, to raise the temperature of substance by 1 degree Celsius is not same. Okay, iron need more heat to increase temperature 1 degree Celsius. This copper needs less temperature as compared to iron to raise 1 degree Celsius, and this lead need minimum heat as compared to iron and copper to increase 1 degree Celsius temperature. So look at initially suppose we say 100 degrees Celsius temperature of all three balls, but still due to this concept we can predict that heat absorbed by all three balls are not equal. Iron absorb more heat, this is in intermediate heat, means not more than iron or not less than lead, and lead contain minimum heat if their temperatures are same. Due to what? This concept, specific heat capacity. This concept tells that the amount of heat required to raise the temperature of substance by 1 degree Celsius. Okay, that heat is called specific heat capacity of that particular substance, and it is denoted by letter C. Okay, so you have to remember here definition of specific heat capacity, and that is why that definition is what, the amount of heat required to raise the temperature of substance by 1 degree Celsius, and that heat is called specific heat capacity of that particular substance. Okay, so if reason is asked about these three balls, why iron ball go deeper as compared to copper and lead ball, so we have to say that initially their temperature is same, but their acquired heat is not same. Okay, temperature is same, but their acquired heat at that temperature is not same. That is depend on specific heat capacity. Okay, iron has more specific heat capacity as compared to copper and lead. So whether temperature is same, but to raise that much temperature of iron we need more heat as compared to copper and lead. Okay, so that is why heat in iron ball is more as compared to copper and lead, and that is why that iron ball go most deep point as compared to lead and copper. Okay, now we have to see unit of specific heat capacity. Okay, so SI unit of specific heat capacity is joule per kilogram degree Celsius, and CGS unit is calorie per gram degree Celsius. Okay, in SI unit it measure joule per kilogram degree Celsius, and CGS unit is calorie per gram degree Celsius. Okay, so such a way that specific heat capacity can be measured in these units. Okay, so one chart of specific heat capacity is given. Okay, so if you see, water has specific heat capacity is 1 calorie per gram degree Celsius. Okay, means if you take 1 gram of water, okay, and we want to increase its temperature by 1 degree Celsius, then we have to provide it 1 calorie heat. Okay, so next is paraffin. Okay, if you want to increase the temperature of 1 gram paraffin by 1 degree Celsius, then we have to provide 0.54 calorie heat energy to that paraffin. Okay, so such a way that if we see iron, okay, so in case of iron we need 0.110 calorie per degree Celsius, that is the specific heat capacity of iron. Then copper 0.095, and the other metals are also given there. Okay, silver is also one there. Okay, so in case of silver we need 0.056 calorie of heat energy to require to raise 1 gram silver's temperature. Okay, so such a way that iron has, in compared to these two cases, lead and copper, what higher, that is the specific heat capacity. So it will be at same temperature, it will acquire more heat as compared to copper and lead. That is why it will go deep inside the wax layer. Okay, so such a way that specific heat capacity is nothing but the amount of heat required to raise temperature of substance by 1 degree Celsius. That heat is called specific heat capacity of any particular substance. Okay, so now we have to formula how much heat substance will be gained if we increase its temperature by delta T degree Celsius, and if we decrease temperature by delta D degree Celsius, then how much heat given out from that substance. So now next topic we have to see, that is the heat absorbed by substance if temperature raised by delta T degree Celsius. Okay, if initially somewhat substance is at normal room temperature, but if we heat that substance by suppose 10 degree, 15 degree, 20 degree, then how much heat that substance can be absorbed, that we can calculate. Okay, how? Look at, for that we have to know mass of that substance, then we should have to know specific heat capacity of that substance, and how much temperature we increase. So by using these terms we can calculate the how much heat that substance can be absorbed. So look at here, specific heat capacity of substance is denoted by C. So the substance we consider, that we have to increase temperature by delta T degree Celsius, we call its specific heat capacity is C, its mass is M, and change in temperature. Okay, so how much degree Celsius temperature we have to raise, that is the delta T. So heat absorbed by that substance is nothing but the mass of that substance into specific heat of that substance into change in temperature. So this formula gives us the amount of heat absorbed by substance when we raise temperature of substance by delta T degree Celsius. Okay, such a way, if some substance have initial temperature somewhat high, then we decrease temperature by delta T degree Celsius. If we decrease temperature by delta T degree Celsius, then amount of heat given out from substance will be equal to again m into c into delta T. Okay, same formula we have to use when we increase the temperature of somewhat substance or we decrease the temperature of somewhat substance. So generally change what happen, if we increase the temperature, then that substance will be acquire that much heat, that is nothing but the mass of that substance into specific capacity of substance and raising temperature, and amount of heat given out when we decrease the temperature, that will be equal to mass of substance into specific heat capacity of substance into change in temperature of the given substance. Okay, so such a way that you have to remember this formula. Formula is same when we increase temperature or decrease temperature, mass into specific heat capacity into change in temperature. So by using this simple formula we can calculate change in heat energy. Okay, so remaining topic we will see in tomorrow's lecture. Thank you.